Today we're going to talk about the general circulation of the atmosphere. This includes looking at the direction of the wind, the Coriolis effect, why and where air rises or descends, and how the general circulation impacts the climate in certain areas. So when we're looking at direction of wind, it's affected by three things: the pressure gradient, Coriolis effect, and in the lower pressure areas, is friction. This is caused by the change in air pressure, and wind goes from high to low pressure. The high pressure is packed with these molecules, more molecules than lower pressure. It makes it feel crowded, so that's why they want to move where it's less crowded. Wind usually moves in a straight line except when there's the Coriolis effect, or if friction occurs, which acts an opposite force of motion, slowing down the wind. The greater the difference in the pressure, the stronger the wind. And as you can see in the picture, there is some explanations and figures showing the gradient wind, and then how the Coriolis force also affects, as well as friction. The Coriolis effect has to do with the rotation of the Earth. The wind moves in a straight line, but because the Earth rotates, the straight line ends up deflected, looking like a curved line. This only affects the wind direction, not the wind speed. Because of this, the wind isn't always high to low pressure as it would normally be. Eventually, the Coriolis force is equal to pressure gradient force, so that they are parallel to the isobars. This is also called geostrophic winds, and they only occur in the upper winds. So why air rises and descends all has to do with the temperature of the air. So starting at the equator, high pressure winds will diverge outward, so they will move away. And this is usually where you see your good weather because there's not any cloud formation. The low pressure winds converge inward, and this is where you'll see your bad weather because the clouds will form and create precipitation. In this image, you can see how whenever there's an updraft, the warm, moist air is rising, and the cool air is descending or converging. So just like we were talking about on the last slide, convergence and divergence have a big impact on the climate and the general circulation. Around the equator, there's an equatorial low, and around this area is where you will find the air moving either upward towards the 30-degree north and south, or it will sink down toward the surface. Where it sinks is the subtropic high, and this is where a lot of the deserts are because there's not a lot of clouds. It's clear skies, and it's just kind of dry because there's not any precipitation. Now around the polar highs, by both of the poles, it's going to be a little bit cooler because the subpolar belt and the polar easterlies and westerlies all kind of combine, and this creates the cloud formation, so you're going to see a lot more of storms around here in this area. Thank you guys for listening, and I hope that I was able to provide you a little bit more information on the general circulation of the atmosphere. And I have posted the links to all of the pictures I've used in my slides.